Hey guys, eighth grade math with your cool down help. We are looking at the first problem here on the back. Got a couple of parallelograms that we're wanting to know if they're similar or not. So you got to explain if they are similar. So the first thing you should be checking for are the corresponding angles equivalent. So those correspond after a little bit of a rotation, right? And the 125 corresponds with that 125, and the 55 down here corresponds with that one. It looks like all of your angles that correspond are equal. So that's the first thing that you want to write down. Okay. How do we know these are similar? Well, we know they're similar because the corresponding angles are all equal. Okay, that's the first part. Okay, but we got to also prove that the sides have grown by a common scale factor. Okay, so the corresponding angles are all equal. So to do that, what I'm going to do is I'm going to make a little table over here. Okay, for my big parallelogram versus my small parallelogram. Big parallelogram on the left, smaller one on the right. And we're going to make a table of the sides that correspond with each other. So like this 4 up here corresponds, and the big parallelogram corresponds with the 3 that's over here. So they go together. And then the 6 that's on the left corresponds with the 4.5 that's over here. So 6 and 4.5. So to prove that these are similar to each other, we've got to prove that they have a common scale factor. And to find a scale factor, whenever you have a table like this, all you have to do is divide the number on the right by the number that's right next to it on the left. So, like you could set up a fraction, 3 divided by 4, or 4.5 divided by 6. They're both going to have the same ratio if they're similar. So, you can check this with a calculator if you want, and I can pull mine up here. We can do 3 divided by 4. If I clear this, 3 divided by 4 is 0.75, and the other one is 4.5 divided by 6. If they have the same constant of proportionality, which they do, then we know that they're proportional. They have the same constant. So let's go back here. We know that our multiplier to get me from one side to the other, wrong page, sorry. We know that our multiplier to go from one side to the other is simply just 3/4 or 0.75. And so, to add to our explanation, we know these are similar. The corresponding angles are all equal, and the scale factor that relates corresponding sides is 3/4. And so, with the angles being equal to each other and all of the sides being able to be multiplied by a common scale factor, that proves that they are similar to each other because it can shrink and it can be rotated and translated over to make match on the other one. All right, moving on. Triangle DEF is a dilation of triangle ABC, and they have a scale factor of 2. In triangle ABC, the largest angle measures 82 degrees. What is the largest angle measure in triangle DEF? A lot of students read this problem and they say, hey, scale factor of 2, so I'm going to double 82 and my answer is going to be 84. That's wrong. When you dilate a triangle or any kind of dilation, the angles never change. So if your angle in the first triangle, the biggest one is 82, well, the largest one in the next one is also 82 because the angles don't change. They stay the same with the dilation. Okay, let's move on to the last one. And for the last one here, we're going to create a little table of the large triangle compared to the small triangle. It tells me that they are similar, so I know that there is going to be a scale factor that gets me across. So there's going to be a constant of proportionality. So let's set this up with parts that correspond with each other. 9 is the shortest side, which is down here. So 9 corresponds with 3. So I'm going to put that in my table. And if I look at 21 down here, that's the longest side, and that corresponds with the longest side over here. So 21 corresponds with A, which we don't know right now. And then lastly, we'll do this beautiful pink color here. And that is the side we haven't talked about yet. So in the larger one, it's called B, but in the smaller one, it's called 5. Okay? And to be able to find out A and B, we need to find out the relationship that is between the 9 and the 3. So if we look between the two that are here, there's a relationship between 9 and 3. And you might have found that this direction is easier to pick out because it's simply just times 3. So I can take the number on the right, times it by 3, and I will get the number on the left. So that helps me find out that 5 times 3, B equals 15, right? And if I want to go in reverse, I can multiply by 3's reciprocal, which is a third, or take a third of 21, which is 7. So A is 7 and B is 15. And that's your homework help for this week. Don't forget it's due Thursday instead of Friday, and we have a quiz on Thursday as well to make room for our Family Friday. Have a good one, guys. See ya.